All right, hello, my wonderful students. This is section 6.4, combining radical expressions. This is foldable 3. For this one, we're going to be combining radical expressions. All right, so we have, what is the simplest form of the fourth root of x cubed divided by the eighth root of x squared? You're going to be like, Mister, they have the same index. We cannot combine them. But yeah, that would be true for the last section, but it's not true for everything, because of course there's tricks to everything in mathematics, which makes it so wonderful. So this is what we're going to do. We know we can change these from radical form to exponential form, so that's what we're going to do. We know that this is our power of m, and this is our nth root, so we're going to change this to x to the 3 over 4, and we're going to change this one. Once again, we have an nth root and an nth root and a power of m. So we have x to the, 2 over 8. And once again, we're a little bit in trouble, right? Because we don't have, so once again, the radicand are different, but the powers of, they're the powers of the same variable. So, which is fine. But because they're the same variable, we can do this. So this is something we learned in before. When we're doing division, we can actually subtract. So that's what we're going to do. We're going to take our x to the 3 over 4, and we're going to subtract our 2 over 8. So this can't really be done, but we can actually reduce this. Reduce. Oops. And we have our, do a little side math here. We have our 2 eighths. If we divide both the top and the bottom by 2, we end up getting 1 over 4. And our 1 over 4 does have the same denominator, so that means we can add. So we're going to go ahead and change it back to the color. So we have x to the 3/4 minus 1/4. And now we can go ahead and say this is x to the 2/4. And once again, we can reduce again. So we're going to go ahead and reduce here again. And we divide both by 2 again. Go and do that in red. Divide by 2 and divide by 2. And we end up getting our x to the 1/2 power, which ends up looking like the square root of x. So once again, I know the radicands were different here. So I'm just going to write it out. So let's do that in green. So the radicands were different, but are powers of the same variable. Okay, so the same variable here, x and x. So that's why we can go ahead and change it. If this was x, y, and x, it wouldn't necessarily work. So now, because of that, that means we can write the expressions using exponents. Exponents. Okay, and this is all for basically this part here. And then the second part, what we did is we used the quotient rule. So we used the quotient rule, something like that, right? For the exponents. Okay, and the quotient was basically if you have x to the m over x to the n, this is going to be equal to x to the m minus n. This is in the previous foldables. And then just in case you don't remember the product rule, this is the quotient rule. So it's going to be I'm going to call the Q rule. And I'm going to call the multiplication rule, or the product rule, I'll just call it the P rule for product rule. It's going to be if you have x to the m times x to the n, this is going to be x to the m plus n. And this is just kind of side notes so you remember what they are. And these are, this one is actually going to explain this up here. This is just a side note, just to remember you have the quotient rule and the product rule for that. And after we reduce, we can go ahead and find our wonderful, wonderful thing that ends up being our square root x.